we are Anao.
and Daesung Kim.
Today we will introduce key dynamics concepts from physics.
Aristotle classified motion as natural or unnatural. Believing unnatural motion requires force. For example, a vase on a table naturally falls to the ground and disturbs but appears unnatural if it remains on the edge without falling. Or rather than natural motion was called unnatural and was thought to require applied force to be sustained.
Galileo's inertia principle states that an object maintains its motion unless acted upon by an external force. Then what is balance force? Balance forces cancel out when two equal and opposite vectors sum to zero, causing no motion change.
When these vectors are summed, they added up to a zero resultant vector. Unlike balance force, unbalanced forces change an object's state of motion. Then what is an equilibrium force? Equilibrium force occurs when a force sum is zero. Then any one of the contributing forces exactly balanced all of the others.
If the sum of all forces on an object is zero, then any unknown force must be the equivalent of all the known forces. The weight of an object is the force of gravity of an object.
Moreover, forces are classified into gravitational, electromagnetic, and nuclear.
Gravitational force is a long-range force proportional to mass influencing objects across distances. It shapes astronomical structures, controls planetary motions, and governs celestial processes.
Secondly, electromagnetic force is formulated by James Clerk Maxwell as the unifying theory of electromagnetism. The electromagnetic force, as is now called, is also a long-range force.
Lastly, the strong nuclear interaction force binds together the particles from the nucleus, while the weak nuclear interaction force is involved in several modes of nuclear decay.
Finally, we will discuss three types of Newton's law of motion. Newton's first law of motion explains that every body continues in its state of rest in a right line unless it is compelled to change that state by forces impressed on it.
The second law of motion believes that a change in a motion is proportional to the motive force impressed and is made in the direction of the right line in which the force is impressed.
Lastly, the third law of motion states that to every action there is always an opposed and equal reaction, or the mutual actions of two bodies upon each other are always equal and directed to counterparts.
We can explain how Newton's first law of motion operates with an example of pulling a box. If two people pull a box from different sides and it has balanced forces, the velocity of a box remains constant and there is no occurrence of acceleration.
However, a box will move if only one person pulls a box because a non-zero resultant force exists, and the velocity changes, resulting in an acceleration. Also, a box will remain the same unless you apply a balanced force to move it.
Newton's second law of motion gives an operational working definition of a concept of force. As you can see on our slides, the acceleration of a system is directly proportional to the sum of forces acting on the system in the same direction as the resultant and is inversely proportional to its mass.
Lastly, Newton's third law of motion can be well depicted by the example of hammering on nail. If you exert a force with your hammer, a nail reacts by exerting the same force on the hammer. This is how Newton's third law of motion works.
둘, 셋.
Thank
Thank
you
you
for
for
listening.
listening.